Okay, quick question for you. What do baking a delicious, fluffy cake and, say, an old iron bicycle rusting out in the rain actually have in common? I mean, to the naked eye, absolutely nothing, right? But if you strip away the context and zoom all the way down into the molecular level, you are watching the exact same phenomenon unfold. It's a chemical change. Both of these are undeniable, everyday examples of atoms literally rearranging themselves to create something entirely new.
So, welcome to this explainer. Today, we're zooming way past the macroscopic world we interact with every single day to uncover the invisible rules that govern it all. We're calling this one The Hidden Recipes of the Universe, Foundations of Matter. We are going to strip reality down to its absolute bare essentials to see exactly how everything around us is built, quite literally, from the ground up. Here is our roadmap for today. Number 1, chemistry is everywhere. Number 2, meet matter and its states. 3, sorting matter, pure or mixed. 4, elements, compounds, and atoms. And finally, number 5, the laws of chemistry. Let's get into it.
Section 1. Chemistry is everywhere. Look, chemistry definitely isn't just confined to laboratories or isolated to people wearing white coats holding beakers. It is the operating system of our reality. Seriously, before you even left the house today, you interacted with countless chemical miracles. The fluoride in your toothpaste, the complex plastics shaping your smartphone, the cement forming your driveway, the sophisticated fertilizers that grew your breakfast, and of course, the life-saving antibiotics and vaccines that keep us healthy. Chemistry is simply the study of all these amazingly diverse substances and exactly how they interact with one another. Moving on to Section 2, meet matter and its states.
All right, let's actually define the fundamental stuff of the universe. Matter is simply anything that occupies space and has mass. From the physical screen illuminating your face right now, to the invisible air filling your lungs, to a heavy vein of gold deep within the earth. If it takes up physical space and carries weight, it's matter. It's the tangible fabric of existence.
Now, what dictates how all this matter behaves physically is surprisingly simple. It comes down to personal space. In a solid, like a block of ice or a steel beam, particle distance is incredibly small. The atoms are locked rigidly together, which gives them a fixed shape and a fixed volume, with almost zero compressibility. But if you increase that particle distance just a bit, you get a liquid. You still have a fixed volume, but now it has a flowing, adaptable shape that just conforms to whatever container it's in. Spread those particles really far apart, suddenly you've got a highly compressible gas, totally free of any fixed shape or volume. So, the physical state of reality is really all about how much space exists between the pieces.
Section 3, sorting matter, pure or mixed.
When we sample matter, we essentially sort it into two major buckets. Pure substances contain only one type of particle with a rigid, fixed composition. Think of a 24-karat gold bar or a perfectly sterile drop of water. It's uniform right down to the atomic level. Mixtures, on the other hand, are just a physical jumble of different substances sharing the exact same space. Think of the complex soil in your garden or the atmospheric air you're breathing right now. They're physically grouped together, sure, but they aren't fundamentally bound to each other. And those mixtures, they break down even further based on their visual and structural uniformity. So if you stir salt into water until it completely vanishes, you've created a homogeneous mixture. It blends perfectly, giving you a seamless, uniform composition throughout. But if you dump some coarse sand into that exact same glass of water, well, the sand just sinks, creating distinct, highly visible layers. That obvious lack of uniformity makes it a heterogeneous mixture. The defining factor here is simply whether the components camouflage perfectly or stubbornly refuse to blend.
Which brings us to Section 4, elements, compounds, and atoms.
I want you to think of an element as the ultimate, indivisible Lego block of reality. It's a pure substance made entirely of one specific kind of atom, like pure hydrogen, oxygen, iron, or gold. The absolutely critical takeaway here is their extreme resilience. Elements absolutely cannot be broken down into simpler substances by any chemical method, period. They are the absolute baseline ingredients of our universe. But what happens when you actually snap those baseline Lego blocks together? Well, you get a compound. While an element relies on just one single kind of atom, a compound consists of two or more completely different elements that are chemically bonded together in a strict, fixed ratio. And unlike elements, these compounds actually can be chemically dismantled back into their individual parts. Pure water, H2O, is a perfect example of a compound constructed from elements. And this brings us to the molecule,
A molecule is the smallest particle of a substance that can exist independently and still fully retain its chemical properties. It's essentially a grouping of atoms that can survive on its own out in the wild. Water roams the universe, has independent molecules. Even the breathable oxygen in our atmosphere prefers to have a buddy, traveling predominantly as stable two-atom molecules, or O2.
Now, at the absolute bottom of our microscopic zoom-in journey sits the atom. The atom is the smallest, solitary unit of an element that you can possibly isolate while still retaining the fundamental properties of that specific element. One single, solitary atom of hydrogen, one single, solitary atom of oxygen. It is the core, indivisible unit of our chemical reality.
Just to clear up a very common point of confusion here, an atom is that single, solitary unit. A molecule is a group of those atoms structurally holding hands. H represents a solitary atom. H2 represents a molecule. It's really just the simple difference between a highly capable individual and a deeply connected team.
Finally, Section 5, the laws of chemistry. The first absolutely unbreakable rule of our universe was proposed by a guy named Antoine Lavoisier, and it essentially reveals that reality is the ultimate recycling facility. The law of conservation of mass states that mass can neither be created nor destroyed. During any chemical reaction, the universe never loses a single microscopic piece. It only transforms them into something entirely new. The total mass of your starting ingredients will always perfectly equal the mass of your final product.
And the math proves this beautifully. Take exactly 4 grams of hydrogen, chemically combine it with exactly 32 grams of oxygen, and your yield will be exactly 36 grams of water. Not a single fraction of a gram is lost to the void. No magic tricks here. The atoms are simply elegantly reassembled into a new configuration.
Next up is the law of definite proportions, thanks to Joseph Proust. This mathematical rule dictates that a specific compound's chemical recipe is completely non-negotiable. A compound will always contain the exact same elements in the exact same proportion by mass, no matter where you find it in the universe or the specific process used to create it. Water on Earth has the exact same mass proportion as water found on a distant freezing exoplanet. This strict cosmic adherence to recipes is exactly why we rely so heavily on chemical formulas. These formulas are the universe's ultimate shorthand. Reading H2O, CO2, or CH4 guarantees exactly which elements and precisely how many individual atoms of each are permanently locked into that specific compound. That mathematical blueprint never, ever wavers.
So, we've zoomed all the way from the everyday objects resting in your hands right now, down to the unbreakable mathematical laws governing single atoms. You now possess the invisible recipes of the universe. So, I leave you with this. Look around the room you are sitting in right now, through this new microscopic lens. What unseen chemical transformations are silently unfolding around you at this very second? Keep questioning, and I'll see you in the next explainer.